Hi everybody, welcome back to our YouTube channel. In today's video, I am going to solve today's Leetcode problem. Today's Leetcode problem is 1288, remove covered interval. So first try to understand the problem statement and after that we will see the code. So in the problem statement, we have given an array interval. So interval consists of two elements, that is left eye and right eye. Represents that left eye interval consists of bond. It means that this include in the interval and this element not include in the interval because this is not bounded. Remove all the intervals that are covered by another interval in the list. Okay, so given that a interval AB is covered by the interval CD, it means that suppose there are two intervals, that is A and B. This is AB and another interval, that is CD. So this interval AB is covered by CD if this condition satisfied, that is C is less than equal to A. Here this condition satisfied because C is less than equal to A and also B is less than equal to D. So B is also less than equal to D. So whenever this condition satisfy, it means that this smaller interval will be covered by this larger interval. So we have to remove this interval. So we have to count that how many interval left after removing all the covered interval. Okay, so let's try to see example number one. Okay, so see, in example number one we have given three interval. Let's take a number line for better understanding. Okay, so number line will be 0 1, that is if I take here 3 dot dot and after that take 6, also take the 2 and after that take the 8. Okay, so first interval consists of, this is 4. First interval consists of 1 to 4, so this is our first interval, and second interval is consist of 3 to 6, so this is our second interval, and third interval consists of 2 to 8. Okay, this is our third interval. So see, as you have see that this interval is completely covered by this interval, so there are no any sense of this interval, so we have to remove this interval, and after that what are the interval left? So this interval and this interval are left, so we have to return the count of the left interval. So in this case we have to return the 2, and if I consider these cases, so in these cases we have given two interval. Okay, first interval is from 1 to 4 and second interval is from 2 to 3. So see, this 2 to 3 interval is completely covered by this 1 to 4 interval. So in these cases we have to remove this interval and return 1 because finally one interval will be left, so we have to return the 1. So let's try to understand the approach of this problem using the whiteboard. Okay, so let's see, this is our interval and we have to remove, our aim is to remove the covered interval, and covered interval is defined as, suppose there are interval A and B is covered by interval C and D. So if A is less than equal to C and also, sorry, this is incorrect. See, C is less than equal to A and B is less than equal to D, then this interval is completely inside this interval. So if this condition satisfies, then we have to remove this interval. Okay, so for this what I will do, first sort the given interval on the basis of the starting point. So see, if I sort this interval on the basis of a starting point, then our interval will look like 1 4, and after that this comes first because starting point on this is smaller than this. So after that 2 8, okay, and after that 3 6. Okay, then start the see, then what we will do that first take this interval. So this interval is starting point is considered as x1. So this is 1, and the end point of interval is x2. This is 4, and after that traverse the interval from I plus 1 to till n minus 1. Okay, so whenever we saw any interval, whenever we saw any interval starting point is greater than x1. Suppose this is our interval at I is equal to 1th position. Okay, so whenever we saw interval of I and 0 is greater than x1, or interval of I or 1 greater than x2, it means that these interval are totally separated from this interval. So in that cases we have to increase the con plus plus, because we get two separate interval. Okay, so in these cases we have to increase our counter variable, because we have to find the total number of separate interval. And if this is true, then we increase the count pointer. Okay, and we have also increased these things, because whenever any interval second, that is end point, is greater than the previous interval end point, because see, the first element are sorted because we have used sorting algorithm. So after sorting algorithm, all the first occurrence, that is the starting point of interval, are in sorted order. Okay, but second, that is last point, are not sorted order. So we have to change this interval again and again. So the condition of changing this interval is that whenever we get any interval start end point is greater than the previous interval end point, then we have to change this interval starting point to the interval we have given. So after increasing count plus plus, so our x1 will be is equal to 2. X1 is equal to 2, that is interval dot I0, and x2 will be what, interval of I1. So our x1 will be now 2 and x2 will be 8. So this statement only execute, then we get the current last interval is greater than previous last interval, because then we are going to change the interval x1 x2. Okay, so now the x1 is 2 and x2 is 8. So again we move at this position. So whenever we saw any separate interval, so separate interval is only possible when the start point of the current interval is greater than x1. So yeah, this is greater than x1, but the end point is 6, but here x2 is 8. So we are not going to increase count plus plus, because this is not a separate interval. So in these cases the count variable is 2, because initially we start with count variable 1, because initially we have considered this as a interval, because there are no any merging of any interval that occurs one time. And after that we check the second interval is separate or not. If second interval is separate, then we increase the counter variable. Okay, so let's try to summarize the approach. So basically in this algo, what I will do, first sort on the basis of first element in the interval. So after sorting, these all elements are sorted. So our interval will look like 1 4 and 2 8, and after that 3 6. Okay, after that what I will do, take a counter variable that is equal to 1, because initially we take this interval as a valid interval, and after that we start iteration from I is equal to 1 and check whether this interval is a separate interval from the previous interval or not. If this is separate from previous interval, then increase count plus plus. So for finding separate interval, both the interval of, that is the second start is greater than previous start, and second end is greater than previous end, then we increase the count variable because we get separate interval. And if this not happens, then we are not going to increase counter variable. And the next step is to we have to update x1 and x2. x1 barabar initially 1 and x2 barabar 4, so we have to update x1 and x2. So for updation of x1 and x2, whenever we see 8, that is the current end is greater than the previous end, then we have to update x1 x2 is equal to whatever the current start and current end. So and at the end we have to return the count variable. So this is our algo. Hope you will understand this algorithm. So let's try to see the code for better understanding. So see, as I have discussed that we first see we have find the length of the interval, and after that we sort the interval. So after sorting, all the starting point of interval is in sorted order. So after sorting, this happens, and take a count variable, that is 1, because we assume this interval as a correct interval. So the count variable is initialized with 1, and after that see x1 and x2 is initialized with 1 and 4. x1 is equal to 1 and x2 is equal to 4. Okay, and after that run a loop from I is equal to 1. So run a loop from I is equal to 1 till m. Then we find is this interval is a separate interval from this previous interval. So for finding separate interval, this position, that is start point of both the interval, a start point of both the interval are greater. So see, in these cases this start point is greater than this start point, and end point is also greater than this end point. So yeah, this condition is true, then we increase the count is equal to 1 time. And after that, for updation of x1 and x2, so we have to update x1 and x2 only when this end point of current interval is greater than the end point of previous interval. So for this we have checked interval end point, that is at 1 index, if greater than x2, that is the previous interval, then we have to update the interval, and after that we count whatever the element remaining in the interval. Remaining element will be all elements that are not covered by any interval. So this is the code. So if you try to submit the code, then you will get the correct result. So yes, this is the correct output for this test cases, and if you try to submit for all the test cases, then you will get the correct result. So thank you for watching the video. See you in the next video.